Alright, for this example, we see that the equation that we're given of the ellipse is not in what we called standard form. We don't see the fractions, we don't see the equals 1, we don't see the parentheses. So what we want to do for this equation is we want to convert this to standard form. Alright, after we convert it to standard form, then we'll find the exact values of the center, the foci, the vertices, and then we'll graph it. Alright, step 1. Step 1 is to identify all of the variables that are being squared. So we have x squared and we have y squared as well this time. So I'm going to gather up all of the x terms together. And I want the quadratic term, so the squared term, and then the linear term next. And then I'm going to leave a blank. So I'm going to put plus a blank. We're going to leave room for the completing the square process. All right, now I'm going to find the y terms. So I have y squared and negative 18y. I'm going to gather those together. It doesn't really matter the order. You can do the x's first and then the y's, or the y's and then the x's. But we just want them to be in order and side by side. I'm going to put plus a blank. Now anything that doesn't have to do with a variable being squared, so any constants, in this case I'm going to move over. And when we move it over, it's going to change signs. So be careful with your signs there. We're subtracting 9 from both sides. We talked about in the last video, whatever I do to one side, I have to do the same thing to the other side. So I'm going to leave these 2 blank spaces on the left, and then I have also 2 blank spaces on the right. Alright, so step 2. This is a little bit different from the parabolas, so we have to be careful here. We want to make sure that the number in front of the squared terms is a positive 1. Okay, right now, that's a positive 1, right? That's an implied 1. This is a positive 9. So, the number in front of x squared and y squared has to be a positive 1. So how do we fix that? Well, we're going to factor out the number in front. Alright, so the number in front of those square terms, we're going to factor that out. So what does that look like? Well, for the first group, there's really nothing to do. We're going to factor out a 1, which doesn't change anything. So we have x squared plus 6x plus that blank. Now here something is going to change. Officially, factoring out really means to divide out. So we're going to factor out a 9. We're going to divide out a 9. We have to do this from every single term that contains a y. Okay, so everything that has to do with the y terms, we're going to divide out a 9 from those terms. So that means we're going to pull out that 9 and we're going to put it in front of parentheses. Now when I divide 9 by 9, we get a positive 1. So I get really just y squared. Negative 18 divided by a positive 9 is a negative 2. So I get negative 2y. I don't know what this number is, so I'm just going to say plus a blank. Okay, so it was an unknown number before, still an unknown number when I divide by 9. So that's a little different than the parabolas. That's okay. Alright, step 3 is we're going to complete the square. So that means that I'm going to take half of the linear term. That's a positive 3. Alright, and then we're going to take that and then we're going to square it. We're going to add that in to the blank. Now remember, whatever I do to the left side, I have to do exactly the same thing to the right side. So in one of those blanks, I'm also going to put that positive 9. Alright, we're going to do the same thing to the y terms. We're going to find the linear term, and I'm going to half that. So basically think about what we said, dividing by 2. So negative 2 divided by 2 would be a negative 1. Then we're going to take that, and then we're going to square it. So negative 1 squared is a positive 1. Now here's where we have to be careful. Okay, here's where we have to be careful. We're not just going to put a plus 1 over here on the right hand side. Here's why. If you were to take this positive 9 that we factored out and you were to multiply it back in, you would get back up to where we started. So positive 9 times y squared, that would give us back to 9y squared. Positive 9 times a negative 2, that would get you back to negative 18. But if you take a positive 9 and you multiply it times a positive 1, you actually would get a 9. So actually, up here in this space, you would have a 9 sitting there that you didn't have before. So what we're actually going to consider is what happens when you take the number that you factored out and you multiply it back into the parentheses. We want to say what number would you have sitting in that blank that you didn't have before. So that 9 is actually going to be what we add into both sides. So you notice that for this one, this first one, we didn't have to worry about that because we didn't factor anything out. The 9 that we have sitting here would still be the 9 that we would have added in to the left-hand side, and that would be the same 9 that we add into the right-hand side. But for the y terms, we have to take into account that we did factor out a 9 from all of those terms. If we divided out a 9 for all those terms, you have to think about, well, what if we went backwards and multiplied that 9 back in? What would we have sitting back up here after we multiplied that 9 back into all those terms? That's the number that we have to add to both sides. All right, so that's going to pop up again in the next several problems, so you want to kind of pay attention to what happens when you have to factor out a 9 or factor out any number to the front, how that changes what you put in the blank on the right-hand side. Okay, so step 4 says we're going to factor. So that means that I'm going to look at the x terms and I'm going to think about how do I factor that. And remember that we said it's always the variable in the parentheses with the half you took. So it's going to be x plus 3 squared. Alright, now what about the middle? We're going to factor this. Right? Factor the y terms. It's always the half I took. So it's going to be y in the parentheses. And this time it's a minus 1 squared. So pay attention to the signs. Really significant that you keep the sign basically that was on that middle term. Equals, and I'm going to add all of these together. Negative 9 plus 9 is 0, plus 9 is 9. Alright, and we're adding in between, oh, forgot our 9, we got to bring that down as well. Okay, so that got factored out to the front and it's still out front. Alright, so we're really close. Remember, our goal is standard form. We need two parentheses squared, we need denominators. We also have to have on the right hand side, we have to have the equals 1. So our next step is to make the number on right side to be 1. So I'm going to divide 9 by itself and I get a 1. Now, I can't just do that to the right side of the equation, I have to do it to everything on the left side as well. Alright, and we want to reduce our fractions. 9 goes into 9 one time. So for that middle, I basically end up with y minus 1 squared divided by 1. And then over here, there's nothing to cancel out, it's just x plus 3 quantity squared divided by that 9. Alright, so this is our equation in standard form. Alright, now looking at that, I should be able to pick off all the information that I want and be able to graph the equation. So I should be able to tell you what the center is. It looks like the center is negative 3, comma, positive 1. We can go ahead and graph that if you want. Negative 3, positive 1, there's the center. In order to find the vertices and the foci, we need to know what is A, what is B. We also need to come up with our orientation, right? Okay, the orientation for an ellipse comes from finding the larger denominator. There we go. And it's underneath the x term. So the orientation is that the major axis is parallel to the x-axis, which means it's horizontal. So we draw our picture. I'm going to highlight that our major axis should be horizontal. Alright, so there's our orientation. What about the A, B, and the C? We know we need those. Alright, the A value, B value, C value. The larger of those denominators we said was always A squared. So A squared is 9. That means the other value, the other denominator, the smaller one is going to be B squared. Alright, so the A, B, and the C will be the square root, right? So A squared is 9. That means A has to be the square root of that, which is 3. B squared is 1. Well, turns out that the square root of 1 is still 1. And then our C value comes from that formula. C squared equals A squared minus B squared. So C squared is equal to the A value, what we have, A squared is 9, right? Minus the B squared, which is 1. So we get C squared is equal to 8. Take the square root of both sides, we get that C is equal to the square root of 8. Now if you want to simplify that, you can. You can write that as, what's that, 2 square root of 2. And then you can also work to find the approximation of that if you wished. Alright, and I believe the approximation for that is about 2.8. So if we want to use that, we've got it handy. Alright, so let's find our vertices and our foci. The vertices are going to deal with the A value, and remember the foci come from working with the C value. Alright, so our A value is 3. Let's go back up to our picture. Okay, we determined that we have a horizontal major axis, so I'm going to draw a horizontal line just to remind ourselves that everything we care about, all the important things we plot, have to be along this major axis. Alright, so we said the A value is 3, so we're going to go to the right 3 units and plot a point. We'll go to the left 3 units, plot a point. And then we're going to label those points. Let's see, on the left that would be -6, comma, y value of 1. And to the right that would be an x value looks like of 0 and a y value of 1. Alright, the B value we said was 1. So we're going to go in the opposite direction, 1 unit up, and then 1 unit down. We don't have to label those. Those are the endpoints of the minor axis. Just going to connect those with a smooth curve as much as I possibly can. It doesn't have to be perfect. Alright, so there's our ellipse. What about the foci? Well, the foci are going to start from the center of the ellipse, and we're going to go to the right and to the left. We said exactly, was that square root of 8? But the approximate value of that was about 2.8. Okay, so if I go to the right, 2.8 units, it puts me about right there. Remember that distance right there we said was the square root of 8. Go to the left about 2.8 units, it gets really close to that vertex. That's square root of 8 distance as well. Alright, so let's see if we can label those points. Let's kind of use our strategy that we've talked about already. What is going to be true about the foci that I already know? Well, look at the y value of all of these points. They all have the same thing in common, right? They all have a y value of 1. So I know that's going to be true of the foci. They will also have a y value of 1. Okay, so that's because they all lay along the same major axis, the same horizontal line, and the y value of that line is always 1. Okay, what's the formula for the foci if I have a horizontal major axis? Well, the x value is what's changing because I'm moving to the right or to the left to plot that point. So it would be the h value of the center, so -3, plus or minus the c value, which is the square root of 8. And that would be the exact values there. Okay, if you wish to plug that in your calculator to find an approximation, you can. But what I will be asking you for is the exact value of that foci. And if you want to use the formula that we've talked about, you can. Or if you want to draw the picture and think about what those changes would be, you can do that as well. Alright, this is another equation of an ellipse that is not in standard form. And we want to rewrite it in standard form. And then we are going to graph the ellipse. Alright, so first thing, I'm going to organize all of the x terms together. So x is being squared, so I'm going to keep it on the left-hand side. I'm going to gather up all those x terms together. I'm going to leave a little space, a little blank for what I'm going to add in. Then I'm going to put the y terms, y squared term first, and then just the y term. The order really doesn't matter, but just alright, anything that doesn't have to do with the variable, I'm going to move to the other side. And that is going to change signs, so it becomes a negative 64. So be careful about your signs when you bring things over. So step one is kind of an organization of the equation. Step two, we want to make sure that what's in front of the squared terms is 1. So it has to be a positive 1. So in order to do that, we're going to factor out the number that's in front of x squared and of y squared. So from the first group of x terms, I'm going to factor out a 25. Now when you factor out a 25, you're essentially dividing out each of these terms by 25, including the number we don't know what it is yet. Alright, so that's an x squared. 100 divided by 25 is plus 4x. Number we don't know, still number we don't know. Alright, now if you multiply that back in, 25 times x squared, you should be able to get back the original terms that you started with. Okay, and we do. Alright, so here I'm going to have to factor out a 4. So we're going to divide each of these terms by 4. So I'm pulling out that positive 4. And I'm going to write inside what's left over after I divide out by 4. So I'm left with a positive y squared, a negative 8y, and then number I don't know divided by 4 is still number I don't know. Alright. Step 3 is to complete that square. So we're going to take half of the linear term. That would be a positive 2. And I'm going to square that, and I'm going to put that in the blank. Now here's where we have to be careful again. The 25, if it gets multiplied back in, has to give me back the terms that I have up here. So if I do that to the constant that I just put inside of the parentheses, 25 times 4 would actually give me a 100 that's sitting on the left-hand side of the equation that wasn't there before. So when I add this number to both sides, it actually has to be the number I factored out times the constant that I put inside the parentheses. So I'm actually going to add in 100 in that first blank on the right-hand side of the equation. Alright, now let's do the y terms. We're going to take half of that linear term, so that's a negative 4. Remember, taking half means dividing by 2. We're going to take that number, and then we're going to square it, and so we get a positive 16. Alright, once again, we want to be careful. When we multiply this number back in, we have to get back the terms that we started with. So when I do 4 times 16, I get 64. That's actually the number that's now appearing on the left-hand side of the equation that wasn't there before. So I'm going to add 64 to both sides. All right, step 4, we're going to factor. You want to be careful here as well that we bring down the 25, so the number that we factored out front of the parentheses, we have to bring that down. And then we're going to factor what's actually inside of the parentheses. And remember that it's always the variable and then the half you took. So the plus 2 here, that's what goes inside of the parentheses. We're going to say plus 4, and then I'm going to factor the y terms inside of the parentheses. So that trinomial would factor as y minus 4, that's the half we took, squared. And then on the right hand side, we're going to add all these terms up together. Negative 64 plus 100 plus 64 looks like it gives me a positive 100. Step 5, we want to make what's on the right hand side, we want to make that to be a 1. So we're going to divide everything through here by 100. Basically, you're dividing by whatever the constant is on the right hand side, you're going to divide that by itself. 100 divided by 100 gives us the positive 1 that we want for that standard form. For the middle terms, we want to make sure that we cancel any common factors in that fraction. Divide here by 4, divide here by 4. 4 divided by 4 is 1, so I just get y minus 4 squared. 100 divided by 4 gives me 25. So we'll cancel any common factors there. Both of these factors are divisible by 25. So I end up with x plus 2 squared, and denominator of 100 divided by 25, that gives me 4. Alright, so now we have our equation in standard form, and we should be able to pick off all the information that we want and then also graph the ellipse. Alright, so what's the center? Let's start there. We would have x plus 2, the center there would be negative 2 for that x value of the center. The y value of the center then would be a positive 4. Now what's the orientation? The larger of those denominators is 25, and that's underneath the y variable. So we're going to say that the major axis then will be parallel to the y-axis. In other words, it's going to be vertical. Okay, we draw ourselves a little picture there. Just a nice visual to keep in mind what we've already decided. Okay, so now we need to know what is A, B, and C. Okay, the larger denominator we assign to be A squared. The smaller denominator then is B squared. So A value would be 5, square root of 25. The B value will be the square root of 4, so that's 2. To find the C value, we use our formula. C squared equals A squared minus B squared. So we get C squared equals, what is that, 25 minus B squared, which is 4. And that gives C squared is equal to 21. So we're going to take the square root of both sides. We get C is equal to the square root of 21. Alright, if you want to, we have the exact value. If you want to find the approximation, I think it's about 4.6-ish. Okay, so if that comes in handy, we can use that. Alright, so let's find our vertices. Remember, the vertices are going to come from that A value, and the foci are going to come from the use of that C value. Alright, so let's go back up here and start to draw our graph. Okay, the center is negative 2, comma positive 4. So here's the center. I'm going to draw a vertical line to remind us that the major axis is vertical, which means that the foci and the vertices will be plotted on this major axis. So everything's going to be on the same line. All right, so where are the vertices? Okay, so our A value, we said that was 5. All right, so we're going to go back to the center, and we're going to go up 1, 2, 3, 4, 5 units, since our A value is 5, and that's our first vertex. We're going to go down 1, 2, 3, 4, 5, so go down a distance of 5 for that A value, and there's another vertex. All right, can we label those? What is that? -2, +9 for the top one. And then this lower one would be what? -2 for x, and then the y value of -1. All right, now let's look at our b value. The b value is 2. All right, so go back up here. We're going to go back to the center and then go 2 to the right, plot that point. We'll go 2 to the left of the center and plot that point. So that comes from knowing our b value is 2. Once I have the vertices and the endpoints of the minor axis plotted, then I can draw the ellipse. Alright, so there's our ellipse. The last little bit that we need is what are the foci. Alright, the foci come from the use of that C value, and we know that's approximately 4.6. Before we go and look at the graph, let's just come up with what that point would have to be. When I look at all of the points that I've accumulated so far, I see that all of them have an x value in common of -2. Since we have a vertical major axis, the x value of all of these points that I plot on the major axis is always going to be -2. Okay, so it's always going to be the same. So I actually know that the foci are going to be -2 comma something. Since we have a vertical major axis, we know that the formula would be h comma k plus or minus c, because the y value is changing as we move up and down along that vertical major axis. So our k value is 4. Our c value, we've already determined, was what? Square root of 21. Alright, so now they all have the same x value, but the y value is changing for each of them because we're moving up and down, and that y value is going to change as we move up and down. Alright, now if you wanted to plot the foci, knowing that our c value is about 4.6, we said, we can start at the center and go up 1, 2, 3, 4, and about halfway up. There's one foci. Go back down to the center, go down 1, 2, 3, 4, and then a little bit more, about halfway. There's another foci. Okay, now it should make sense. The values that we have should make sense with our approximations as well as the exact values that we've already found. The x value of both of those points is still clearly -2. The y value, we started at a y value of 4, and then we went up about 4.6, right? So that would be like saying 4 plus, we know square root of 21 is the exact value, but if you were curious about the approximation, you could use that 4.46. So the point approximately should be about -2, 8.6. So that makes sense with the point we plotted. That's an approximation. The point down here, if this distance is about 4.6, we start at a y level of 4, and if I go down, then I'm subtracting 4.6. So the point we plotted should be at about -0.6, and that makes sense. It looks like it's at about -0.6 for that y value. So if you want to verify your exact answers by looking at the approximate and how you graph them on your graph paper, then that might be a good little check, a good idea to just check with that approximation. But keep in mind also that what we were looking for all of these, we were always requested for the exact values the unrounded non-approximation values for each of these points.